And then if you get sucked
Okay,
into
so
something
I,
you're studying.
I think we're at least recording now. We're not online, but it's week 8 and we're here. I got the laptop finally working and the Bamboo plugged in, and I think what we'll do is just start off and cover a few things with Problem Set 1. I had a few students email me and say, gosh, I'm going to have to, grab a math tutor, et cetera. But, we have, up to now, done a lot of these problems in class. So my first bit of advice is, just watch the lectures, take your time, work them over. There are also some good resources out there. If there's some math that I forgot or need to learn, I'll go out there to the Khan Academy and just type in the keyword. Say you need to remember, Pythagorean theorem, or I can't remember that, or the quadratic formula. Just go out there in 5 or 10 minutes and learn these things. I have not looked up units conversions on the Khan Academy, but that would be my first step. Just
How do you spell that?
Units. Khan is K-A-H-N.
No. That Khan.
Yeah, and unfortunately I can't get out to it. I think it's just.
I actually used your paper from Summary 1 as a reference. There's a section on page 442, human energy consumption.
Okay.
Home energy consumption. So I just used those to base units to work from there.
Oh, nice.
There's also quite the amount of tables of conversions in the back of the book.
Yeah, the book does have some good tables for conversions. So, give me one of the problems that we should just work on first of all. Is it just daily human metabolic?
Yeah.
Okay.
So I just started with 2,000 nutritional calories.
Yeah.
And then converted from there.
Yeah. So let's do that. So we're going to go from energy.
Set number one. Yeah, you should get something else.
Energy per person per day. So one way to write that, you could just say, energy, put a little subscript P, and then D for day. So that's how you'd write it mathematically. And would you start?
Okay, I skipped that.
Well, because you want to set up as a fraction, and we use E for energy, and what kind of energy? One person energy, and then there's D for day. So you can even think of it as a slope of a line. X
So
rise over
then
run.
you would just plug in the numbers to the E and D when you say like 2,000 calories a day?
Yeah, you would.
A day?
That's exactly what you do. And so what that equal, and you said 2,000? So that's 2,000 big C calories per day is what you start with. And what's the problem asked for? Where do you go from there?
It asks for thermochemical calories with a small c.
No, yeah, it asks you to convert into little calories, big calories, joules, megajoules, BTUs, therms, and kilowatt hours.
Nice. Okay. So we know that there are 1,000 little calories per one big calorie, right? So from there, really, all I have to do is multiply that times dot, whatever you want, parens, doesn't matter. There's a lot of different ways to represent multiplication. Pick your favorite. I'll just put a little dot here. 1,000 little c calories per one big C calorie. And then from there, it's just a matter of elimination. And again, like I said last time, all of these units conversion problems, you're really keeping track of 3 things. You're keeping track of the arithmetic, which is really just the numbers here. The powers of 10, which is this chunk right here. There's multiple ways to do that. And then the units, which is this chunk right here. So there's your arithmetic, here's your units, there's your powers of 10, and here are your units. Units. So that's a little a, that's a 10, and that's a u. So arithmetic, powers of 10 units. So from there, I'm going to cancel this unit with this unit, and I'm going to multiply the 2 by the 1 and get 2, and I'm going to multiply all those zeros together, and I'll just go ahead and write it out as 2 million little c calories per day. So again, just you tell me, what's the D there? Is that an arithmetic? Is that a power of 10, or is that a unit?
Unit.
It's a unit. How about this 1 here? Is that an arithmetic, power of 10, or a unit? I'll call it arithmetic, yeah. Yeah. So every one of these units conversion problems is really doing that, just that. So the next one, and again, we can just start with that, probably easiest to start with that 2,000 calories. Let's do it one more time. Let's just go to BTUs. Per day. Now, how many BTUs per calorie? Oh, yeah, go ahead.
Is it okay if we just went ahead and took, because I found conversion factors between them through the list.
Yeah.
So what I did is I went and did like the 2 million calories into, does that work? If you convert, instead of going from calories every time to a different unit, but
Yeah, you can hop
convert
around.
to unit,
Yeah, once
like
you-
just in a row.
Whatever is easiest.
Yeah, there's really,
That's what made
yeah, I'm not gonna-
sense to me,
right,
you know,
yeah.
So that was kind of caught, I guess.
Can I throw one caution in there, though?
Yeah.
Your 2 million calories came from a calculation, whereas 2,000 big calories are a fixed number. If you screw up anywhere in your calculations, then every single one of your answers is
Yeah,
going to be
I
wrong.
caught on to that one.
that's actually a fantastic point, Tim. Thanks for bringing
Today
that
doesn't
up.
matter. Today probably doesn't
Sounds
matter.
good.
As you get farther into
Yeah,
this,
definitely will.
Well, that's why you want to show it works.
That's a good word about it.
Yeah, no, it's a good point, and what Tim just pointed out, it's just called error propagation. If you make the error the first time,
Then it's just all.
it will propagate through the rest of the problem.
My only question there is having conversion factors for everything, for like calories to everything. You might not always have a conversion factor, you have to kind of use 2 or 3 in a row.
No, you might, yeah, you're correct, you might not have a conversion factor from every unit to another. And I unfortunately can't get on line right now, but there are some great websites that'll convert between any
Anything, yeah.
units,
Yeah,
yeah.
I checked it.
I did use that too, but I try to stay traditional too at the same time.
Well, you should do both. I mean, honestly, go to your textbook, and
I double-checked all my
we've,
stuff
yeah, we've done this
using
multiple times in the course too. We've even done it, a little fact check with the, energy densities of fuels and things like that. See what it says in the book, then go check it online for sure, absolutely.
Yeah, Chapter 2, primary energy, is a great source. I went from little calorie to joules because in the book it says 1 calorie is equal to 4.19 joules.
Right,
There you go.
right,
I was able
that's a
to
good one.
convert easily right there.
Yeah. Okay, so somebody tell me, so let's just go back, we've got 2,000 kilocalories, what's the BTU to kilocalories conversion? Wish I knew it off the top of my head, I just don't. Is that something,
I mean, I could pull out my.
is it in the book? I'm
my
kind of hoping
set
it
on
is.
my computer right now.
Yeah, I think it is in the book.
So let's be democratic, let's just have a few people look it up and let me know what that number is. I just don't know it off the top of my head.
Democracy.
Yeah, we went from back and forth.
All right, so we will get to BTUs. So we're going to start and just say that 1 little calorie equals 4.2 joules. So let's just run it like this. We already know that 2,000 kilocalories are 2 million calories per day. So I'm just going to go ahead and write equals 2 million little calories per day. So I'm just going to take this little equation, and really, when you look at this thing, if I were to divide the left side by the right side, or vice versa, what number am I going to get? So if I divide 1 calorie by 4.2 joules, what's the number? What's the value of that? Or vice versa, if I divide 4.2 joules by 1 calorie, what does that equal?
Calories per joule.
What number does it equal? Well, okay, I'll write it out
1
then.
divided by 1.2 or 4.2 divided by 1?
Well, 1 calorie divided by 4.2 joules equals,
Calories per joule.
He wants a number.
Oh, wait.
it equals 1.
6. Oh, right.
That's key. I mean, that's really key to understanding the whole
Divide it
thing.
into 1 equals 1.
Well, these two things equal each other. It's exactly the same as this. 100 cents equals $1, right? So it's the same as saying 100 cents divided by $1 equals 1. That's it.
And it's just weird because like dividing us, like a smaller number by a larger number equaling 1, it just doesn't, my brain's like, like, you know what I mean? But I see what you're saying.
Well, that's, okay, so that's valid, and it all goes back to the fact that you're solving 3 problems at the same time.
Mhm. I see what you're saying.
And, you can do it the same way. $1 divided by 100 cents equals 1.
It's once you add the units in, like, those are just numbers, then it obviously wouldn't equal.
Yeah, that's how the units balance the numbers. It's the whole point I mean, that's really the entire point for using the units. So it's something we can deal with. Just all the way back to, how long is a foot? Well, it's as long as the king's foot is, because it's a pain to measure everything in nanometers. Or, same thing, or how much do you weigh? Well, what was the British still use the stone sometimes?
Oh, yeah,
It's 14 pounds.
Yeah.
14 stones. But it's kind of, it's easy. If you're out there, 14 pounds is kind of easy to pick up, and you're weighing things on very analog, no digital scale, you're just on a balance. So, anyway, okay, so that's the point of using the units. Okay, so here's 1 calorie is 4.2 joules. So now all we need to do is just multiply this by the number 1. And I'll write it one more time. 4.2 joules divided by 1 calorie equals 1. Same thing, I just did with the dollars and the cents. So when I multiply 2 million calories per day by 4.2 joules per 1 calorie, just get this, 4.2 joules per 1 calorie. So we'll take care of the arithmetic first. There's that chunk. 4.2 times 2 is 8.4. Now we'll take care of the powers of 10 next. And I'll just write that as 10 to the 6th. 10 to the 6th. And then we'll take care of the units next. There's a unit, there's a unit. The calories cancel. We're just left with joules per day.
So,
Go ahead. Yeah.
So is it okay if I did like really exact numbers and I didn't round up? 'Cause
You can use exact numbers. Good question on the numbers.
Yeah,
Significant digits. Let's just do that really quick.
okay.
Another way to write this is 8.4 megajoules per day. And remember, we've talked about 10 megajoules per day, and that's about right. If we'd used 2,500 kilocalories instead, we'd be closer to 10. Okay, so question from the back, significant digits. So let's say we do this. Let's multiply, let's just multiply the number 11. How many significant digits there? 2. And we'll multiply that by 500. How many significant digits there? There's actually only one.
Zeros aren't.
Yeah.
Zeros aren't significant
The-
unless
the-
it's come before a whole number.
The zeros are not significant unless they're coming after the decimal point.
Okay.
Now, if this were, it's the same thing as, well, I hate to use this as an analogy, but, how many people died in the last hurricane or earthquake? And I said, well, it's about 500. Maybe it's 450, maybe it's 450, maybe it's 550. We probably just don't know at this point. Eventually you get out, well, okay, so 515 people died. Eventually you'll get to that number. So a number like this, there's really only one significant digit. You can, treat it like 2 depending on the situation, but if we multiply 11 by 500, here's 5500. This would be correct, but there would be no point in putting all these extra zeros out there because you just don't know. I mean, you weren't given that much information initially. We did the same thing with 4.18. What was it, joules per calorie? This has 3 significant digits, and you know that. And let's just say you started with 2,000 calories. There's really no argument to go beyond using these 3 significant digits. So if you're using 4 significant digits in any of these problems, you're using too many.
Okay.
Yeah.
I think part of that too would be how exact are the numbers for your input? Because your 2,000 calories is not an exact number.
Yeah,
I mean,
right.
you don't
Yeah,
cut
I
'em
guess
in.
to start it, it's like about 2,000 calories, but
Yeah.
when you go and you see what a calorie is equal to, how it's equal to another unit, so then that number is exact. So then you put in your 2,000, so even if your 2,000 isn't exact, that's the number you're putting in. So
Yeah.
it has to, you can't say like, oh, well, it's about, this much, once you get past that point, so if you choose your number.
Yeah.
Basically, and
Yeah, it's
that's just how I was looking at it, so I was just using the numbers that were exact in my calculator and
Yeah.
everything. So I could round up and simplify it to significant digits, but I just didn't know that was.
An easy way to measure that is we've got 8.4 megajoules, right? Or,
Mm-hmm.
8,400,000 joules. Do the same thing with your decimals and extend it out 8 and multiply that out and see what number you come up with. You might come up with 2 or 3 extra joules. Out of 8,400,000 is probably not that big
Yeah.
a factor.
Yeah, so, and just to reiterate, in all of these problems, 3 significant digits is the standard. Yeah,
So even if your unit conversion is larger than 3 digits, like 1,000?
absolutely.
4 digits?
Absolutely. If it's, let's just say, well, let's just do the problem like this. And 2,000 calories. And I don't know the number, I'm just gonna make this up. Let's just say it's 4.18205 joules per calorie. You can multiply the whole thing out, just go ahead and do it. So 2,000 times 4.18205 equals, did I do that right? Yeah, 8364, 8364 for joules. I think there was a decimal point there. So it's actually incorrect to include that.
Okay.
And in fact, it's technically incorrect to include anything really past these first two, so that would just become, well, 8,400. That's the correct answer.
Okay. Even if it's like 40.
What's that? It is,
You just
yeah.
round up? Is it just because it makes?
It is because, no, well, just think of it this way.
Yeah.
How many calories did you have today? Are you actually going to know to the tens of calories? You're not.
But
I mean,
you
you-
could know joules and BTU and things like that. so you
No,
can
no,
just
no, no, no. Having a very precise conversion does not make the initial information more precise. Does that make sense? Yeah, I mean, I don't know, go out to McDonald's, they'll tell you exactly how many calories are in that burger, but there's variation. I mean, those last couple significant digits, maybe they didn't squeeze the rest of the fat out before it came off the grill, or, or didn't shake that basket of fries that last time to get the oil off, or
Or
whatever.
maybe you didn't eat like a fry here or a bite of it there.
Right, or maybe, fry snuck under the
So
carbs.
everything is an estimation, is what you're saying.
Everything is an estimation.
Yeah.
So exact mathematics is really not
Well, 'cause
exact.
it's not like every person is
I mean, I'm
consuming
aware
the
of
same
that, but I've
amount
just
of.
been, being told different, you know what I mean?
Well, I mean,
Just so
that
it's
not
just
every
like, what's the
person's
point
like
then?
consuming 2,000 calories a day either, like that's an
Yeah.
average.
Right.
Exactly.
Well, all the
It's an average, yeah.
variables too, that you'd have
So
to
because
include
we're-
this make it a huge, impossible thing to figure out, because everybody's
So-
different.
Well, it's not impossible to figure out, but you're gonna know, you'll know this part, you'll know it to the 100th of a calorie. You can be certain of that, but you just don't know these.
So what if you're starting with a variable that is known or is exact?
Sure, yeah, if you're in a physics lab and you are measuring the mass of the electron to
Yeah,
20
yeah.
significant digits, absolutely, you're gonna use them all.
So just because we started with a variable that is, an average or an estimation, then the rest of our numbers have to kind of go along with that?
That's right, when you're multiplying significant digits, you always have to defer to the least known of them. And in this case, this is 2, we're gonna call that 2, and so we're only allowed to use 2 in our final answer.
Gotcha.
Yep,
Yep.
perfect, okay. So really, what I've shown you here for these conversions, it's the exact same thing, time after time. So just to review, what we did, we took the word problem, and this is just kind of how the world works. You go and talk to your architect and you say, hey, I want a room that's 20 feet by 10 feet. Like those words were spoken, the architect is going to then take that and turn it into a drawing with that shape, and then they say, oh, well, how much is that going to cost me to heat? Well, how many heating degree days do you do? You're going to have this English conversation, but all of that is going to get converted into something quantitative and numerical. So, we started with the word problem. That was step 1. We converted that into algebra. That was step 2 down here. Energy per person per day. And I prefer to use the subscript because we're talking about energy. We've been using the letter E to represent that. And rather than confuse and confound, just use a single letter for the variable. And then the convention for one day is just the letter D. No reason to write the number 1. We could have, but we didn't. So the question stated, using either 2,000 or 2,500 calories per day, kilocalories per day, convert that into other units. I showed you that each one of these, you're dealing with some arithmetic, a power of 10, and then a unit. We did a multiplication. There's equals, and there it is. So we saw that we went from the algebra to the actual solution. I also showed you another way to think about units conversion, because we know that 1 calorie equals 4.2 joules. When I divide 1 calorie by 4.2 joules, I get 1. When I divide 4.2 joules by 1 calorie, I also get 1. So what I'm showing you here in the units conversion, I'm just multiplying by 1 every time, and that's allowed. And you're into, like, why would I want the same answer? Well, because you're speaking to someone who wants the answer in joules, or BTUs, or therms, or kilowatt hours, et cetera, et cetera. So it's the same problem time after time. Okay, let's take a break there, and I think there's one other problem that someone had a question
Yeah,
about.
the number 5 has to do with the rate of